bi and a minus bi. That's called a complex conjugate when your a's match and your imaginaries match, but one's positive, one's negative. So we're going to go ahead and see what happens, although some of you might already know, because of this on a different pattern. A times 8 is 64. Then we get minus 8i plus 8i. And then negative I times negative 1 gives me minus I squared. Well, what's going to happen to those middle numbers? Yep, they're going to cancel each other out. So we get 64 minus, and what are all I squared? Negative 1, right? So now what's 64 minus negative 1? 65, right? That is your answer. So it went from imaginary, they're complex conjugates. When you have that situation, it's going to end in a real number. Does that make sense to everybody? All right, go ahead and do number 12 on your own. So when we FOIL, 5 times 5 gives me 25. 5 times 4i gives me positive 20i, then minus 20i. Then we get minus 16i squared. What will happen to my middle terms? Cancel out, right? So now we have 25 minus 16 times negative 1. So negative 16 times negative 1 gives me positive 16, and what do I get? 41, good. Walking around, the vast majority of you got that, and if you didn't, it was a simple error. So any questions on number 12? All right, this next part, the divided complex numbers, my biggest concern with this is when we talked about rationalizing the denominator, a lot of you didn't know what that was. But do you remember when let me go to a different screen, don't write this down, just follow along. When you had something like 5 divided by the square root of 3, we talked about how irrational numbers in the denominator can't happen. With calculators, modern day, it's a little bit better, but with imaginaries, we don't do it. What did I tell you to multiply by to rationalize it? Aiden? Very good. And we multiplied the top and the bottom by that so that we kept our fraction proportionate. Right? So then that put the irrational number up into the numerator. Square root of 3 times square root of 3 gives us 3. You guys remember that? We did it real quick on the board. We're going to be doing the same idea because we can't have imaginary numbers down in the denominator. So we have to think about these complex conjugates. We're going to get back to that because notice how it made it a complex number turned into a real number. And that was our goal. Same thing with I squared turns into a real number. So we're going to use those concepts so that we don't have imaginary down in the denominator. Everybody with me so far? Even if you don't know how to do it? Okay. So right at number 13. Well, let's read right here. It says, watch out. I cannot be in the denominator of a complex number. So if it is, we're going to multiply the top and the bottom by I. If it's a monomial, meaning one term. If it's a binomial, we're going to multiply the top and the bottom by the conjugate. The conjugate is what we just did here. So we have two things going on in this section. The first few, we only have an I down here. So let's try this one. If it's a monomial, we're going to multiply the top and the bottom by I. So we're keeping it proportionate, basically multiplying by 1. But it's going to move the imaginary up into the numerator. So if you go straight across, 10 times I gives me 10i. 2i times I will give me 2i squared. That's the first step. What does I squared do? Emily? It's negative 1, right? So we have 10i to this point over 2 times negative 1. I'm going to write out every single step, but you don't have to do this in your homework. So now we have 10i divided by negative 2. Still not done yet. Everybody with me so far? 10i divided by negative 2. Okay. What is 10 divided by negative 2? Yeah, so it's negative 5. Are you guys ready to try another one? Next one won't come out so nice and neat.
So it's real quick, the reason why the 2i was squared was because you're
our imaginary numbers are not the denominator. Alright, so number 14, now we have 4 over negative 9i. So what am I multiplying by? Multiply by I. When we multiply straight across, what's going to be in my numerator? 4i.
Oh, I always mix those up.
Okay. Then negative 9i times I would give me negative 9i squared.
And then when you multiply the negative 9 times negative 1, you get a positive number. That's what I was talking about.
That's what you're talking about?
Yeah, when I said that.
Which would be 4i over positive 9. If we can't simplify it any further, that fraction is already reduced, so that is the final answer. Is everybody okay with that part? Alright, now if you look at numbers 15 and 16, now our numerator is a binomial. So when we multiply by I, we have to distribute that to both parts of that numerator. So you're doing the same thing at the beginning. You're multiplying the top and the bottom by I. If it helps, put this in parentheses. That I has to go to both components. So you're going to get 28i minus, and then we're going to get 8i squared. And the bottom, 4i times I gives me 4i squared. Everybody okay so far? Now you just have to clean it up. Oh.
Without a fraction, because you're going to sit there and you're going to subtract negative 1 with negative 1 with negative 8, that would be positive 8, and then you subtract 4 by 8, right? And you get 4 on top.
Let's keep going. We'll see. You were starting out right. I think you might have gone the wrong direction. So 28i stays the same. Minus 8i, that's negative 1, so that becomes positive 8. 4 times I squared. Negative 4, right? Now with this one, we can simplify it further. Because what is 28 divided by 4? Or 28i, I should say. What did you say? Yep, so we have negative 7. I. And then 8 divided by negative 4.
Are you dividing them though?
To simplify them.
Oh.
You divide both of them by negative 4. Just like what we did in 13, but you just have one term in each. And then we have to flip it. Negative 2 minus 7i. Any questions on 15? Feel easy? Doable, I should say. Why don't you guys try number 16 on your own? What time is it? Let's not try 16. And I feel like we're getting close to the end. What time do we have in here now? Let's do, go ahead and do 16 on your own. I'll do the complex conjugates tomorrow, so it doesn't feel